Hey everyone, let's look at number 18 in section 4.2. We're given this function here and this interval, this closed interval. We're going to find the maximum minimum values of the function on that interval. So the way we do this, of course, is this is a continuous function on this interval. It's continuous for all positive values of x. Remember, the domain for the natural log of x is values greater than 0. And so for values greater than 0, this function is continuous, so it's certainly continuous on this interval. So the way we find the max or mins are, remember, to simply evaluate this function at the endpoints or any critical points in that interval. So we're guaranteed to have a max and min for this function on any closed interval in its domain, and that max and that min will occur at either the endpoints or the critical points. Okay, so finding critical points requires us to find the derivative of this function. This is the natural log of x divided by x, so this is a quotient rule, right? I take the derivative of the top function, derivative of natural log of x is 1 over x times the bottom function minus the top function times the derivative of the bottom x, derivative of x is 1. And so I get basically, notice this is just 1 minus the natural log of x divided by x squared. There's my derivative. So do we have a critical point? Is this derivative ever equal to 0? Well, remind yourself of the natural log function. Remember, the logarithm is the exponent on the base, and the base in this case is e. And so what would the, for instance, natural log of 1 be? Answer, that would be 0, right? Because the exponent on e needed to get 1 is 0. So again, remember, so for instance, the natural log of 1 is 0, since e to the 0 power is 1, right? So the logarithm of 1 is the exponent on the base needed to get 1. Okay. Now, when is this derivative 0? Well, obviously, notice it is undefined when x is 0, but that's not in the domain, right? In fact, it's not in our interval, but this only is valid for values of x greater than 0, and then we're certainly only looking on the interval from 1 to 4. So it's never undefined then on that interval, and it's going to be 0 when this numerator is 0, right? So when 1 minus natural log of x is 0, well, that's going to occur when the natural log of x is 1. Well, if the natural log of x is 1, what's x? Remember, the logarithm is the exponent. So the exponent on the base is 1. And what's the base? E. So x must be e to the first power, which is just e, right? So in fact, when we evaluate the natural logarithm at e, we're going to get 1. And this is the graph of the natural log function. You should be familiar with its behavior. As x approaches 0 from the positive side, we're approaching negative infinity. We have a vertical asymptote of x equals 0. As x goes to infinity, the natural log function approaches infinity slowly, but it does go to infinity. Okay, so there is our critical point. And notice E is about 2.71828, and that's important because we only want to check critical values on this interval. So if I got a critical value of 4.7, I would not include that in this analysis because I'm finding the max or min only on this interval. Okay, so now we simply check the value of the original function, right, at the endpoints and that critical point. So remember, the original function f of x was the natural log of x over x, and the natural log of 1 is 0. So 0 divided by 1 is 0. Here I get the natural log of 4 over 4, and I just use my calculator to approximate that, which is about 0.347. And then the natural log of e is 1 over e, right? So I get 1 divided by e, which is about 0.368. Okay, so again, these are the possible values for our max and min. So what is the smallest value? What's the minimum? Smallest value is 0. So our minimum is 0. What's the largest value? Well, by just a little bit, this 1 over e is larger than the value at 4. So 1 over e is our maximum value. And so that's how we solve this problem. I hope this is helpful.